Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listener's ears to new and exciting technologies they may have not been purview to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And, this week we're kind of jumping back on our 3D printing, I guess you could call it a journey. At this point. We've kind of gone from, what it is to, using in STEM in the classroom, for it. And now we're going to kind of jump back to, what it is. We're going to go back to, what is 3D printing filament, or what is the 3D printing material? Because based on what the different types of printers is a different type of filament or material you're going to consume.
Right. Yeah, and it's crazy because you think about it. We've been talking about making something from nothing. But we're not actually making something from nothing. We're forming, a polymer or some type of blend into something. So it's definitely all of these different materials come with different characteristics and ways they behave, put in different temperatures, different environments. Yeah, there's a whole bunch of different ways that these filaments, resins, materials can kind of react in certain situations, and that's kind of a key part of how you can get a print to work out is understanding the characteristics chemically for these materials.
So for me, what I think was unique and was revolutionary is being able to take something like nylon and printing out nylon and making, say, I want to know how a planetary gear works. And I just need it to be robust enough so that I can connect some type of motor to it so I can actually see it move and visually see how this planetary gear works without having to spend the money of having a machine. So additive manufacturing really benefits from these materials. And what's unique or what's exciting is that we're coming up with new materials all the time. So I believe things like ABS is something that's good that you can use if I'm trying to use it as a model. Maybe I want to make something so I can see temperature changes, and I use a material that responds to different temperatures so I can see, hey, what happens when a brake pad is actually stopping a car? How does the friction and the heat, how's that heat dissipated? I want to make something where I can simulate that so I can teach that in the class. Right,
exactly. And now if you think about it, you go all the way to the point where you're, 3D printing carbon fiber. Carbon fiber is in its infancy, a sheet laid, and resin covered, building material that is formed under pressure, or under vacuum, depending on, how you want to do that. And now we're able to print stuff in carbon fiber. So you've now taken that carbon and resin material and formed it into, one material that acts under a certain way under temperature. So it kind of takes whatever you know about, carbon fiber forming or anything like that and kind of, flips it, kind of on its head. And, I know that, a bunch of us, thought about it and stuff like that. It's like, the resin printers, you have something that's going from a liquid to a solid and it's still attached to a platform, but it starts life as a liquid with an unknown way of how it converts to a solid, but unless it's based off of light.
Yeah, that change of phase was like, it's incredible to see. And there are several different categories of, when we talk about resin, resin kind of exists in a category of its own, but there's other categories within the harder filaments that are more kind of pointing you in the direction of what you're trying to make. Right?
Yeah,
so
like a tactile.
Yeah, so if we're thinking now, we can focus more on the industrial side, where, like Ed said, ABS. Depending on what you're doing, if you're doing gaskets and things like that, TPU. It's probably going to be more of the durable rubbery filament if you need it to give a little bit. But then you get on the other side, we talk about the hobbyist side. So we talked about steam and STEM things. It's PLAs and color changing. If you're trying to print like a prototype and I need all of my parts to be distinctly different so that I can see, okay, so these two operate on the same axis but are on separate parts of my piece. I need them to be related to each other. So visually I can see these two are orange. They move together. So it kind of translates into that industry-wide kind of appeal for that. And then you get into PETG. Now, PETG is probably going to be the jack of all trades. Personally, PETG is my favorite just because it's a cheap filament that's going to have a higher temperature melting point, and it's going to be less rigid than PLA. Now, I don't mean it's going to be hard as a rock. Like, it's going to be firm, but it's not going to snap as easy as, like, say, any type of PLA, shiny PLA, silk PLA or anything like that. So, now, I like the fact that you're talking about the temperature changing filament because, and discovering new filaments because NASA actually, is about a week ago, invented a new filament that can be high temperature, high pressure, and the plan is that they can print it out in space. So in my mind, immediately what I think of, and I think you'll like this, Ed, is I think of a new space station printing itself in space because that's a vacuum, right? So I can control the temperature of my nozzle. That's a vacuum, and if I'm printing with this new alloy that's 1,000 times stronger than any previous alloy we've made that can survive in space, why can't I continuously build out my spaceship, my space station, whatever you need it to be? We're getting close to those steps.
Well, another application that I'm kind of excited about it is 3D printed material that's conductive. So now I can take and start 3D printing transistors microscopically. Now I can start maybe creating switches and maybe devices that are sensitive to temperature or sensitive to sounds and things like that. And then I can use these things. First of all, you would want to use them in a place where you could teach. Because I always think that hands-on is a lot better than theory. Theory is good after you've had a hands-on approach. Once you understand core concepts, then you can get into theory. I think it's always a mistake to try to do theory before someone understands the core concepts. So yeah. I can't build another layer until I have a bottom layer.
Yeah, walk before you run.
And then the other thing that's exciting is, hey, affordable homes.
Yeah.
You know, maybe that's something we can look at using once we get the technology affordable enough. It's there, but it's not there.
Yeah.
It should be as affordable as building an Adobe house. It should be as affordable as making a TP. I mean, housing should be, or anything that we want to manufacture that we want to push out to the masses, and quality to the masses. And something that can be biodegradable. There are now materials that now are biodegradable, and they speed up the process. There are materials they're experimenting with now that can come out with a texture that's acceptable, but I don't have to use alcohol or some solvent to make this thing have a certain texture.
Yeah.
What I would personally like to see, in my opinion, is if I have a part fail, that I have the capability to take something and print it in metal or an alloy, or maybe at titanium or something like that, like Wolverine claws. Maybe I can make something as durable from science fiction to science fact. Those are some of the things I would be interested in. Yeah. With the material.
It's kind of funny you bring up, the affordable housing and stuff like that. The housing market. if you think about it, we have companies out there who are using a 3D printer, but their material they're printing with or their filament is concrete. They're building homes, with a 3D printer using concrete. Concrete is their filament. Concrete is, their medium, if you should say, you'd say. And it's not just that, there's, a couple companies out there in like in Czech where they're making barriers that are bulletproof. So they have a Kevlar reinforced concrete that they're printing with and curing with and sending to other locations, based on what's going on. We won't go into that. But if you think about it, like the DoD does rapid prototyping with a 3D printer in a combat zone to replace parts that fail, on certain things. So the filament is able to handle, temperatures ish. And, when we say, we say that, what is it? Some that can't handle high temp and some that can?
Right, yeah. There's a few that are, they just have higher melting points, let's say. So they can withstand those environments for longer, as well as, let's say you leave them in your car on accident, it's not going to be a puddle in the back seat. Like, that's the last thing I want is to pick up a puddle of plastic that's melted in my car. No, it's not going to be like that. It's funny that you mentioned building the houses, though, because like I kind of want to get back to something we touched on earlier, as like a couple episodes ago, sustainability. The price point that you can now make a house if you're 3D printing it. If you talk material and labor's whole shebang, you're cutting that time that they can build a house. You're cutting the cost of labor. You're cutting the cost, well, probably the same amount of materials, but concrete probably a little bit cheaper, depending on what you're trying to make, or the layout of the home, if you will. But it's something that's like, it's revolutionizing the home building market, and it's just a oversized 3D printer. Like, it's just a giant 3D printer. And that kind of brings into the spectrum what Relativity Space is doing for SpaceX. Yeah. Is 3D printing rockets. Like, that's incredible. To a degree of accuracy. It's level. Like, it's every single line is perfect. It's incredible how much application that has then become. You talked about earlier, printing in metal. It's not the conventional way of printing, right? It's not extruding metal out. That would be kind of crazy to see. You need a forge or something for that. But like, it's actually welding in the layers. So, and these are reusable. Yeah. So it goes back
sustainability.
It goes back into the sustainability. They're re-landing these rockets, reshooting them out. You're taking something that took dozens of people to work on, hundreds of hours, weeks and months of work. We'll do it in a couple weeks. Give me 4 guys.
Yeah. So. Think about that on that same part. You got they're 3D printing the nozzles, the bell housings, for these motors and stuff like that are withstanding these pressures and temperatures of spaceflight.
So I grew up as a kid watching Star Wars and Star Trek. So from Star Wars, space travel, obviously. From Star Trek, we had communicators that looked like flip phones. Guess what? We have flip phones, or we are past flip phones. Another interesting thing I saw is people are now 3D printing food. Now, to me, that's a game changer. There is an application now where people are able to take and 3D print food. It's on a small scale now, but it's not on the scale of like printing enough food to feed a village. But could you imagine if I could take parts from, like, take a Raspberry Pi and give a person a few components and teach them how to build a 3D printer for less than $300, and they could feed a village? Yeah. I mean, then that's empowering people. Yeah. That's giving the person not only the fishing rod, it's getting them the depth finder to figure out where the fish are. Yeah. But for me, another thing was I grew up with the Terminator, and the first version of the Terminator was molten metal or liquid metal. So skeleton. Could you imagine if we were able to take nanobox and marry that with the filament, and then that filament had properties to be conductive, and I can just add a charge from a 9-volt battery, and it did the work. I didn't need the nozzles. I didn't need the heater. The filament itself would actually have the chemical properties to heat itself up to whatever temperature to make it go to that point. I think we talked about it before, a solid and a liquid.
Right.
Yeah.
I think that would be really
now.
interesting.
Yeah. You start getting to the, material with a memory. It's, you got all that stuff. And it's like, if you think about it, you can take all of this stuff that we're talking about, as at a commercial, standpoint, and bring it to the home. You can 3D print half the stuff in your house, if you really wanted to save money. You think about it, a 3D printer is not just, sustainable, like we said, or reusable, or anything like that. There's a piece of reuse to it. But if you have the right filament and stuff like that, or any type of, output that you're going off of, be it concrete, whatever, you can actively print most of the stuff in your house and save yourself money. You're going to spend, what, $300 on a printer? You're going to spend another $17 a roll on that printer, and you can print whatever the heck you want with it. If you think about it, you can get, TPU and print coasters, or PETG, and you can print coasters for your house. You can print, can holders and stuff like that. Stuff that you would go to the store and pay $20, $30 for, you're now paying 20 or 30 cents for.
Yeah.
And it's none of your time. You design it, or you find it on, places like Thingiverse. You download it, you print it, however you want it. You can print whatever you want. And the other thing is most of the filament, once it's printed, pretty much non-toxic, at that point. You can make kids' toys with it.
Yeah, exactly. And I mean, there are a few of them that probably shouldn't be in the room while they're getting printed with,
Yeah.
But for the most part, a lot of these things were kind of made with the idea that the printer is not coming with an enclosure.
Right.
It's gonna have the reaction out in the open. Most resin printers, because now it has a reaction that needs to be controlled, comes with an enclosure.
Right.
So you think about a lot of those pieces, and it opens up your mind to the applications. You talk about printing everything. You can pretty much print everything in your house. Yeah, you could print. The otter boxes. I could 3D print one of those. Your shelves. I could print your brackets for your shelf. Hey, you give me a big enough print bed, I print the whole shelf. I print you a bookcase. Just give me the size, the print bed, and hell, even if I don't have to do the print bed, I can print little models that fit into each other. That you can. Now you don't have to make it in one piece. It can take a lot longer now, but it is what it is in that sense. And you think about those building blocks and all those pieces is it goes back into your own creativity is your limiter. Nick was talking about coasters, right? You in some cases you would have to struggle to find a specific coaster with hey, I want this actor's face on it, or I want this show's emblem on it. I need this in this way, and I have it pictured in my head, and I will not change what I want because that's what I saw and that's what I need. There's nothing stopping you from 3D printing that. There's nothing stopping you from going in Tinkercad, in Cura, in any of these applications, Fusion 360, AutoCAD, any of that stuff make it yourself. Make it yourself. A couple YouTube videos, there's a couple tutorials that are going to walk you through. Hey, the community even encourages you to reach out to them. We want you to take our models. Well, I shouldn't say my models. Our models as in a unit and build on it. We want you to use that. If I see my piece in your bigger robot arm, I see my little gasket over here, I'm still going to be excited for it. Yeah. So it's nice to have those little things around the house as well as the community behind it that will, hey, why is this not working? Let's get your print right. So.
And I hate to keep going back to things because I like comics, I like Marvel, and I like Iron Man, and I like Jarvis. And it's the reason I say I like Jarvis. I would like to see intelligence incorporated into these 3D printers. I would like to see the handheld technology we have so that, hey, a person doesn't have the capacity to do something in 3D Fusion, or the person doesn't have the capacity to do that, but I can take a picture and I can wirelessly communicate with this, and Jarvis can say, oh, I see what you want. How long what size? What color? Jarvis, you know what I like. It will be done in 15 minutes. These are the things that we should be doing. Deep learning, machine learning, AI, all incorporated into these machines. But the thing that I think that most importantly, what people are missing, or the opportunity as a society we're missing, is no one wants to see plastic in the ocean. No one.
Right, exactly.
That's true.
Why are we not setting up recycling centers to grab this plastic and make cheap filament? Why are we not doing that?
Funny thing you mentioned that. All right? And that's a segue to a whole different, bag animals. It's we're on the level of, material, the topic of discussion is material, is you can take a plastic soda bottle and turn that into material for a 3D printer. Yep. You got people out there printing with Mountain Dew, Coca-Cola bottles, Diet Coke. Next we're gonna have people making battle bots. It's gonna be Coke versus Diet Coke. Based on if you can find enough. And this is like, what's better, Coke or Pepsi? I don't know. Let's make a battle bot. And we'll fight them to the death. It's a bunch of plastic, but hey, who cares? But then the thing is once you do that, you can throw it into a shredder, spit it back on the other end, and reuse it. 3D printing is one of those things of where the reuse factor is coming back. And, the filaments, if you do recycle your filaments, please don't put them all in the same box. Because when you go to do that, you're going to have a really wonky a really wonky chemical compound going on that no one wants to be around when that thing goes south. Yeah. Or smell it when it starts heating up and you're like, oh, that's not good.
And that's why we incorporate Jarvis.
Yeah.
And the thing is next thing we'll be down to Batcave. Dealing with that,
But yeah, it's a good idea though. The reusability, it's a good idea. It's something that needs to happen. To Ed's point, we have too much trash in the ocean. We have too much excess trash in landfills and all these places. Why aren't we making those work for us? Why aren't we reusing those? I don't care. Make it into a Pepsi bottle from Coke. It's fine. You reused it. It's okay. It's got a new purpose now. It's the whole point of it. So it's a brilliant thing that you can do that. Now I do want to make one point though, with the mixing of the filaments. It can be done, but you have to be very mindful of what you're doing, because there's such thing as a marble PLA. Mm-hmm. Right now they call it PLA. They say marble because it appears marbly. It looks like it's got the flakes of a marble sculpture, right? And you think about it, is I take this gray or this kind of matte light gray looking PLA, and I sprinkle flakes of a filament that is of a higher melting point. So it will still kind of melt a little bit, but it's going to maintain those spots on that. It's going to stick through. They kind of do it a little bit with, they try to do it with iron and copper, and it'll get kind of these reactions with heating it and things like that and drying, or if it gets moisture, it'll kind of discolor and things like that. They even do sawdust to make it a wood PLA, where you can even stain that filament. Like you can make a sculpture, a wooden sculpture, stain it, make a bench. We talked about shelving.
Yeah.
You could see something stained and not even realize it's 3D printed, because wood's already, unless you're sanding it down, is already kind of rough when you cut it in and of itself. When you stain it, it's going to be nice and smooth, but it's going to look the same. It's gonna be kind of a little bit off, but you're not going to be able to tell the difference. So they can be mixed. You got to be careful, and I don't suggest doing it at home.
Just acknowledge that. Ever look at gargoyles? They say never again.
No.
I just see the world of I've been around electronics since probably I was 10 years. So I've had a long relationship with electronics all the way back to before we had microcontrollers where you were building these things on a breadboard. And capacitors use mylar plastic. Why haven't we figured out another way to use the plastic, using 3D printing, to incorporate this into some of the electrolytic capacitors? Or why are we not using this plastic to, maybe we can use some of the properties where some plastics are susceptible to moisture. Mm-hmm. Maybe I can take that, and when I have an oil spill, I can take this plastic and 3D print it, and it absorbs all the oil because of the properties we incorporate with it. Mm-hmm. Like I said, I grew up with Star Trek. This next generation need to be better than Star Trek.
Yes. Yeah, that's when we're starting to like Star Wars. But it's just, as we go down the filament and the material, strain, we start looking at all the different things that we got out there. You got PLA, you got TPU, you got PTEG, you got, nylon X. Once we start getting to the X's and Z's and Y's and all the other stuff,
carbon fiber with the nylon.
Right. Yeah. You start getting, Kevlar. You're 3D printing with Kevlar. Out of all things, 3D printing freaking body armor because, well, you can't. Think about it. The only thing you can't print is your ceramic plates, for a vest. But I guarantee you somebody's going to figure it out eventually. Just how it goes. We figured out how to print concrete.
Yeah.
All right. And then when you start getting into like the resin printers and stuff like that, where, everything starts with a liquid, liquid to solid, and you really can't go back. That's the only one that I don't think you really can recycle like you can everything else. Because, you really can't turn a solid back. You can turn a solid back into a liquid, but you can't turn it back into the same thing it was. It's just going
to be different now.
it's not going to go in reverse.
Yeah.
However, you're also, and this is the one thing, I know we're getting towards the end of time here, is, you're looking at the different materials that we have out there, is how they're going to look when they're done. If you think about it, what is it? The resin printers have a better for figurines and stuff like that.
Yeah, you won't see the layer lines. It's going to be smooth. It's going to look like it was out of a factory that you went to the store and bought it if it's resin. If it's filament, you're going to see those lines, which we talked about earlier with the wood. It's okay because you got the wood grain, the grain of the wood. It's that there's already lines there. You just kind of blend in. But for most of the filaments, you're going to get lines. We talked about the rockets. They have the lines. Like unless you sand, you're going to have a little bit of line.
Gives it character.
Yeah, there you go.
Character building.
Makes it unique.
Right, exactly.
Like I said, I hate to keep being the oddball, but I'm going to be the oddball. It's my obligation to be the oddball.
Why don't you send us out there, Ed, while you're at it?
So here's another thing to think about, or here's something to challenge your thinking. What if I was able to take the molecules out of the atmosphere and put that into some machine that was a 3D printer and combine those molecules in some combination, whether on a terrestrial planet like Earth or whether in space in Mars? And I was able to take those chemical compositions with Jarvis and do these things with just air. What if I was able to do those things? Not saying that it's possible now, but that's what we should be thinking.
So like a cloud that 3D prints rain?
Well, no, more like a apparatus that pulls in air and it takes the molecules that's in the air, oxygen, hydrogen, or whatever else that's in that atmosphere, and it converts those things into materials.
Yeah.
Yeah, you pretty much can create an ecosystem like the nitrogen cycle or something like that in a place where it doesn't have it. Talking about terraforming a planet now.
Well, ego. A little bit of an ego there.
Yeah.
Ego. Yeah. So, like I said, we always appreciate you guys tuning in. And from myself, we really appreciate the support we're getting. And I'll just let the other two guys just kind of give you their farewell. But as always, we appreciate your support.
So I really appreciate it. First off, I want to thank both Nick and Ed because this is a platform to speak to more than just the group of friends that are already interested in the 3D printing. It gets that word out there. So it's something that it's been stimulating for me and has also kind of made me think differently about some of my 3D printing. So it's been a pleasure the whole time, and I appreciate everybody listening too. So.
It's like, I'll piggyback off of that, and we'll go ahead and end it here in a second. Is, we want to thank everybody. We're seeing that we got some global listeners now and stuff like that, and we're happy about that. We're happy about the people listening to us right here in the good old USA. But more that we can get the message out, more we can get people interested in STEM and STEAM and Industry 4.0 amongst other things. 3D printing. If we can get one more 3D printer in the hands of a kid, or one more 3D printer in the hands of an adult that's interested, we've won. And we're very happy about that. So, we leave you with a charge, go out there and try to learn this, play with it, try to get into Tinkercad and do a little bit of 3D modeling and, go from there, do your own research. And, if you have any questions on it, send us an email and we're more happy to respond to you. So, we bid you, a good day and, hopefully talk to you soon. Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.